All right, guys, we're going to do a quick one. This is at lunch, so you're going to listen to this in about 30 seconds or so. And I just realized my pencil that writes is not plugged in, so hopefully this works right. Let's see what happens. Oh, it does work right now. All right, cool. We're on point now. All right, here we go. So we are moving into a new unit. It's dealing with quantitative and qualitative measures. Still a lot of stuff now. The vocab is going to start kicking in, and you're going to kind of notice a little bit of new stuff, but using the same stuff we did last unit. So let's look at percentile. So so on a test, a student's percentile is is a student's percentile the same as a percent correct? No. So let's like talk about this real quick. So let's say there's 10 people in class, and uh, the student's score is 60%, but he ranked second out of all the scores. Okay, so he ranked second. So in other words, he had he had or actually the ninth highest score, right? Because the rank number one. So he had the ninth highest score out of 10 people. So he was at the 90th percentile. So really, what a percentile is, it's a position of value, okay? And it's with a certain percentage equal or to below that value. So it's a rank of order. So if we rank him, we had score 5, 6, 7, 8, 9, 10. He was the second ranked, right? He was the second ranked here. So below him or equal to were 90% of the scores. So he did as good or better than 90% of the people on that test. So his percentile was 90%, but his overall score was 60%, which kind of happens a lot on AP tests in general. All right, so let's look at this here. So if we're looking at this then, and we have this STEM plot, they can ask you all sorts of different ways. And this is from 2009. It's been a while. Uh, they had 92 wins. So if we look, 5-9 represents 59 wins. So if we go right here, I counted 25. So if I started here and I went one, and then I did two, three, four, five, I counted the 90-second win at 25. So if there's a total of 30 teams here, so I do 25 divided by 30, and that makes 83rd percentile. And so what does that mean? That the Rockies uh, had more wins than at least, I didn't want to say at least, more wins than 83% of the Major League Baseball teams, okay? MLB. So that's the idea. So Rocky had more wins than at least than 83% of the Major League Baseball teams. In other words, 83% or less were lower, did not have as many wins. Man, I'm getting tongue tied because I'm trying to do this fast because you guys are coming in about 30 minutes. All right, so he's going to show up in about 30 minutes. Here we go. So what about 103 wins? Well, 103 wins is the 30th rank, but that's one. So there's this common question of, can we have the 100th percentile? And technically, no. Cannot be There cannot be the 100th percentile, because you're not better than 100% considering you're part of the 100%. So they would technically call that the 99th percentile. You're better than 99%. uh, so they would call that the 99th percentile. So it's percentiles are a little funky, but they're based on order. So, and then we kind of move to the next piece here. So this is called a cumulative relative frequency. You see the word relative frequency? That means it's based on percentages, okay? So let's look at this right here. So this 1.0 is 100%. This 8 is 80%. You kind of see how that works? So the decimals represent percentages. And so now, since it's percentages, we can turn things into percentiles. So let me get my handy dandy shape generator here, and we'll go with green. And it said 57,445. So this is 55. So it's right about here. Let's draw a line straight up, and then we'll draw another line straight across. And, we can say that this thing is approximately the 78th percentile. So the median household income of 57,445 is about the 78th percentile, meaning that it has a median income value of uh, a higher median income value than 78% of the states. Okay, so it has a relatively high median income household. So we just keep working around with this. You can work backwards with these guys. So let me go to shapes again. So they want the 25th percentile, 25%, and then that 25%, I don't know, maybe 47,000. I don't know. My line's not straight. So let's just say it's approximately $47,000, right? So what's another name for 25%? So we would say that Q1 is equal to $47,000. Okay, so when we're dealing with percentiles, we can find our Q1, our Q3, all those different types of things. All right. So if we look at this, since we're talking about steepness of a graph, and we look at these things, and we look at the steepest part of the graph, I'm looking at it like this, like from here to here is like the steepest part of the graph, right? So if we look at this, that's a horrible drawing. That's why I use this straight line drawing thing. If we look at this, that means if I go from here to here and way down here like this, and that's not a straight line. So let's just say that's 10. So if we look at that and we look at this piece here, this is about 5%, let's say, and this is going to be, let's just make it really easy and round it to 75%. So that means between here and here is 70% of the data. So what does this indicate about the distribution? That means 70% of the states are between those points. So on this relative frequency distribution graph, the steeper it is, the more data points there are. Okay, so the steeper it is, the more data points there are. All right, so here we go. We're diving in, guys. So let's look at this here. So I'm gonna draw. I'm gonna draw a straight line here, just because I can. Now I'm just gonna do that. So if I drew a straight line, and let's talk about this. So we're gonna look at this here, and we're going to call this, let's see, the heights of 3-year-old females. Let me do this color here for the females. Females is 94.5, right? And Macy is 100. So let's just call this over here 100. All right. Okay. So then Brody is on another graph here. Let's do Brody down here. All right. And Brody here Brody is 158, but they're, let's see here. So his mean is, we'll just keep it even, 158. No, 149. 149, but he is 158. Okay, he's 158 centimeters tall. So if we're looking at this right here, he is approximately +9 away. She is plus 5.5. Okay, so if we look at this in an absolute sense, so absolute means just a straight subtraction. So the distance between here and here is 5.5 centimeters. The distance between here and here is 5.5 centimeters. So it looks like Brody is much taller according to the graph when you compare males and females at their ages than Brody is. But or Brody seems to be much taller. But when we look at this, we have a piece that we know about, but we don't know how to use it yet, and that's standard deviation. So if I look at this, and I'm going to put the standard deviation in red. So for the boys, we have a standard deviation of 8. So if I go 8 away, right, that's 157. So that's +7 for the standard deviation. So I go up here, +7. Well, I go here and I go to +4. So I add 4 to it. +4 for the standard deviation, and I get 98.5. So if you look at this and you realize that Macy is more standard deviations away than Brody. He's barely above the standard deviation. She's quite a farther than the standard deviation. So on average, it's a big deal that she's this much farther away. So by age, she's much taller when you compare her to 3-year-old females than Brody is when you compare him to 12-year-old males. Now, it's all context too. So if I'm if I'm uh, if I am, let's say, 10 above the average for height, I'm 10 centimeters higher. That's 904.5, right? Not that big of a deal. Yeah, you're pretty tall compared to everybody else, but not that big of a deal. Okay. Sorry, it is a big deal because you're much taller than everybody else. I mean, you're on this one, you're almost 3 standard deviations away. But in dollars, no, because if we're at $94 and we add $10, it doesn't make much of a difference because it's all relative depending to the amount of numbers you use, and it's relative to the amount of standard deviations that we're dealing with. The key to here is the standard deviation. So we call that interpretation that I was just talking about, we call that the z-score. So we use what's called a z-score. A z-score is this: it's the test statistic minus the parameter divided by the standard deviation. This is on your formula sheet. I'm going to get you the formula sheet probably tomorrow. Okay, that's on your formula sheet. You got to know what to plug in there. And for now, we're going to plug this one in there. So let's just talk about, in general, let's just talk about Macy. We know that Macy is at 94. I'm sorry, she's at 100. Let me go back. Equals. Macy is 100 centimeters, right? And we know the average is 94.5 centimeters. And we know that the standard deviation always has the same units, right? It always has the same units, and the standard deviation for them was 4 centimeters, right? So then we get this. We get 6.5. Oops, nope, 5.5. Z. We get 5.5 centimeters over 4 centimeters. And if we stick that into a calculator real quick, 5.5 divided by 4 equals, I don't know why I'm in offline mode. That sucks. Uh, Here we go. Hopefully it worked. Uh, I lost connection. Let me keep going. I doubt it's working anymore.